Welcome to the session. In this session, I am going to talk about concentration cells and their types. So, concentration cells. Concentration cells are one type of galvanic cells. Galvanic cells, we know very well that galvanic cells contain two different electrodes dipped in respect to electrolytic concentrations. And concentration cells are one type of that one. The difference is that concentration cells, the electrodes are the electrolytes, they are similar or identical. Okay. So in galvanic cells, two different electrodes are taken, but in concentration cells, we can take we take both electrodes made up of the same metal. Okay. So similar electrodes or identical electrodes are used. I mean, so for example, two zinc electrodes of same concentration or two zinc electrodes of different concentration. These are used in concentration cells. For in galvanic cells, we use different electrodes. Say for example, a zinc electrode is coupled with a copper electrode like this. So concentration cells are the cells in which EMF arises due to the transfer of matter from one half cell to the other half cell because of a difference in the concentration of species involved. Okay, so a concentration cells we get electricity. The reason is that their potential difference arises because of difference in the concentration of involved species. Involved species indicates here either electrodes or electrolytes. I mean, either electrode concentration is different or electrolyte concentration is different. So if they are made up of the same, their composition is same. I mean, concentration is different. Okay. So this is about the construction of concentration cells. Okay. So here matter will be transferred from one half cell to another half cell. Okay. Uh, this is the about the construction of concentration cells. And for example, we'll take if two plates of the same metal are dipped separately in two solutions of the same electrolyte, and if they're connected by a salt bridge, this forms a concentration cell. Okay, so two plates of the same metal, they are dipped in respective electrolytic solutions, and if they're connected by a salt bridge, this forms a concentration cell. And this is concentration cells are of two types. First one, electrode concentration cells, and the second one, electrolyte concentration cells. Okay, electrode concentration cells, these are also called as concentration cells without transference, and electrolyte concentration cells are also called as concentration cells with transference. Okay, so let us discuss in detail about these two types. First one, electrode concentration cells. I told you already, concentration cells, they contain similar electrodes or identical electrodes, or similar electrolytes or identical electrolytes. I mean, similar means concentration, both are same in composition, but their concentration is different. Similar. Identical means same. They are made up of the composition is same and concentration is also same. Say, I'll give an example. So, two hydrogen electrodes. Okay, two hydrogen electrodes. So, one hydrogen electrode at 1 atmospheric pressure, second hydrogen electrode at 1 atmospheric pressure. So, in this case, both hydrogen electrodes are said to be identical. Similar hydrogen electrodes mean one hydrogen electrode at 1 atmospheric pressure, another hydrogen electrode at 2 atmospheric pressure, or other different pressure. Okay, so two hydrogen electrodes at different pressures, they are similar. Two hydrogen electrodes at same pressure, they are identical. Okay, now hope I am clear with the identical electrodes and similar electrodes. The same is the case with the electrolytes also. Now we'll get into the matter. First type of concentration cells, electrode concentration cells. Electrode concentration cells means electrode concentrations are different. In other words, we can say electrodes are not identical. Electrodes are similar, not identical. And in electrode concentration cells, two similar electrodes at different concentrations are dipped in same electrolytic solutions. And another point here is that in electrode concentration cells or electrolyte concentration cells, if electrodes are similar, electrolytes must be identical. If electrolytes are identical, electrodes must be similar. Okay. Okay, we'll take for example here hydrogen electrodes. Hydrogen electrodes are different pressures. Okay, they are dipped in acid solutions. I mean solutions containing H plus ions. Okay, so similar hydrogen electrodes dipped in identical acid solutions. This is the example here. That is represented like this. See here, we are taking the as hydrogen is a gas electrode. We are taking the help of platinum electrode. So platinum, then we have hydrogen at P1 pressure. So I told you already we are discussing about electrode concentration cells. So hydrogen electrodes are at different pressures. So anode is at P1 pressure. Anode is at P1 pressure. Hydrogen gas at P1 pressure and dipped in single electrolyte here. We can take both electrolytes. I mean electrolytes are identical here. Same concentration electrolytes we can take, or so we can take simply only one electrolyte, and into that one we can dip the uh, hydrogen electrodes at different pressures. Okay, so in the notation, in the representation, only one electrolyte is there, that is containing H plus ions. Okay, and then we have another hydrogen electrode at P2 pressure taking the support of platinum. Okay, so this is the setup. So we have hydrogen electrode at P1 pressure, then that is dipped in electrolyte of H plus ions. Then another electrode, hydrogen electrode at P2 pressure, dipped in the same electrolyte. So this is the construction, okay, of the electrode concentration cell. And let us discuss the chemical reactions occurring at respective electrodes. So at LHE, left hand side electrode, I mean this electrode, hydrogen electrode at P1 pressure, the reaction occurring is oxidation, as P1 pressure of the hydrogen electrode is high, P1 is high, then oxidation occurs at that one. The chemical reaction is hydrogen at P1 pressure gives rise to 2H plus 2 electrons. These 2H plus ions will go into the electrolyte, and 2 electrons will flow towards the uh, other electrode, other hydrogen electrode through the connected wire. Okay, so oxidation reaction occurs at the left hand side electrode. Next, another reaction occurs at the right hand side electrode, that is reduction reaction, as uh, hydrogen electrode at the P2 pressure, that is dipped in electrolytic solution having H plus ions, it will consume the H plus ions. Electrons are arrived, two electrons are produced at the hydrogen at P1 pressure, that will those H plus those two electrons will reach the hydrogen electrode at the P2 pressure, and here reduction occurs, 2H plus 2 electrons gives rise to hydrogen at P2 pressure. Okay, so this is a reaction occurring at the hydrogen at P2 pressure, hydrogen electrode at P2 pressure. Now the overall reaction is hydrogen at P1 gives rise to hydrogen at P2. I mean the condition here is P1 is greater than P2. Now what happens? P1 pressure will be decreased slowly, and hydrogen electrode at P2 pressure will be increased. Okay, or we can say uh, matter is not transferred here actually. Just we are applying the pressures here, P1 and P2. Okay, and EMF of the cell, EMF of this concentration cell is given by E cell is equal to 0.0591 by N log P1 by P2. Okay, so P1 pressure and P2 pressure, substituting those two values, and valency is 2 here. In this case, substituting these values, we will get E cell. And one more point here is in E cell, standard EMF of the cell is 0 in concentration cell, as we are using electrodes of the same composition. Okay, so by using this formula, E cell is equal to 0.0591 by N log P1 by P2, we can find out the EMF of the electrode concentration cell. And another example is amalgam cells. Amalgam cells, you know very well. We know very well. So two amalgam cells of the same metal is taken at two different concentrations, immersed in single electrolytic solution or two identical electrolytic solutions can be used here. So that is also an example for electrode concentration cells. Hope you are clear with the electrode concentration cells. The basic concept here is electrodes are similar, electrolytes are identical. Okay. Next, we will move to the second type, electrolyte concentration cells. Electrolyte concentration cells or concentration cells with the transference. Here, electrodes are identical. Okay, electrodes are same. Their composition is same and also concentration is also same. Okay, but electrolytes they are same in composition, but concentration is different. Okay, and let us take an example. Uh, Zinc electrodes, two zinc electrodes, identical zinc electrodes. Okay, identical zinc electrodes dipped in similar zinc sulfate or zinc sulfate electrolytic solutions. The cell is represented like this. See, zinc dipped in Zn plus 2 of C1 concentration, salt bridge Zn plus 2 of C2 concentration, Zn. See the electrodes here. This is zinc. This is also zinc. Electrodes are identical. Electrolytes are Zn plus 2 and Zn plus 2 here, but they have different concentrations, C1 and C2. And the condition we take here is C2 is greater than C1. C2 is greater than C1. Then the electrode reactions are at the anode. Zn gives us Zn plus 2 electrons. So here the left hand side electrode, Zn gives rise to Zn plus 2, which goes into C1 concentration plus 2 electrons. And at the cathode, Zn plus 2 electrons gives rise to Zn, zinc solid, which is a reduction reaction. Here, Zn plus 2 will be consumed. Zn plus 2 ions will be consumed from C2, and Zn plus 2 ions will be released into the C1. So the overall reaction will be Zn plus 2 C2 gives rise to Zn plus 2 C1. I mean, Zn plus 2 C2 concentration will be decreased slowly, and Zn plus 2 C1 concentration will be increased slowly. Okay, when the concentrations of these two electrolytes Zn plus 2 C1 and C2 becomes equal, we don't get any electricity there. Okay, so in the beginning we'll get EMF, then gradually it will be decreased. Okay, and finally it will be zero, where the Zn plus 2 for C2 and C1 will become equal, and we can use this formula for finding out the EMF of the concentration cell, electrolyte concentration cell. E cell is equal to 0.0591 by n log C2 by C1. As C2 is greater than C1, we will get here C2 by C1. Okay, substituting these two values C2 and C1 and n, we will get the EMF of the electrolyte concentration cell, and we can see in the picture. This is an example of electrolyte concentration cell. We have discussed just now. Zinc. This is zinc electrode. This is also zinc electrode. These two are identical. No difference in the concentration. Both are identical. Both concentration is same. And next, electrolytes are similar here. They have different concentration. This is Zn plus 2 of C1 concentration. This is another electrolyte, Zn plus 2 ions are there having concentration C2. Here the condition taken is you can see here C2 is greater than C1. Then for this condition C2 is greater than C1, we'll get we'll see oxidation occurring at this electrode, left hand side electrode, and reduction occurring here. And this is about concentration cells. And then applications. So concentrations are used for finding out the solubility of sparingly soluble salts. Then they are used to find out the valency of a particular ion in an electrolyte. Then they are also used to find out the transition point between two allotropic forms of a metal. Okay, so metals have two allotropic forms. The transition point, change over for of the metal from one form to another form, that is transition point. That transition point can be determined by using the concentration cells. So this is about concentration cells and their types. Thank you.